First, you log into MySpace. And no, there are no top 8 friends here. This is a live operational view of your SOC where analysts start their day. Here you can see who is on shift and what they are doing. Marcus Johnson is triaging alerts. Hannah Park is monitoring APAC endpoints. You have immediate visibility into live SOC activity. You also have a real-time ticker. It shows incoming alerts and platform activity. For example, John Marco created a new playbook. Jack integrated a new technology. A new analyst joined the team. You can see everything happening across the SOC. This removes unnecessary surprises. If someone is already building a playbook, everyone can see it. System-wide messages keep the team aligned. At the end of the shift, analysts can also hand over directly to the next colleague. Dashboards are very flexible. You can add any dashboard you need. If you want SOC metrics here, you click and add them. We also support AI-generated dashboards. So you can say, "Hey Imperum, I need a new dashboard. I want a dashboard for MITRE techniques. Generate the design." Imperum queries the database and fetches the data. In this case, it found 96 events. Then it suggests 3 dashboard designs. So you can build any dashboard you want using AI. You can also combine them. For example, I want a MITRE attack dashboard like this. Deploy it. And now you have it. So there are no more static dashboards. You do not need our team to build custom dashboards for you. You can create and combine them directly in the platform. This is the first thing. The second thing is multi-tenancy. We support multi-tenancy with subgrouping. You can have one customer or one MSSP and then sub-MSSPs underneath. For example, customer A may receive SOC services, but they may also have 2 or 3 separate locations. You can separate those environments, and I will show that later. Next is alerts. All alerts come here. All of them are normalized. You can view them as flat alerts or grouped alerts. You can also define your own grouping logic. You can see here that the alerts are now grouped. The same alerts from before are now presented in a much cleaner structure. This is the grouping rule. If you click it, you go directly into the group. The first AI capability here is AI Triage. Every single alert goes through Imperum Triage. Let me push these alerts through Virtus Triage. This is very powerful. It does not matter what kind of alert comes in. The system detects the alert type, severity, and MITRE mapping. It prepares a triage plan, executes it, and then returns one of 3 outcomes. It can close the alert as a false positive, it can open a case for the SOC team, or it can determine that there is not enough context to make a safe decision. This happens through real-time tool calling. The LLM is calling your EDR and your CM live in the backend. So it can decide, this is a false positive, I will close it. Or, this needs escalation, I will open a case. Or, this alert lacks enough context, I cannot determine whether it is benign or malicious. You can see that here. One alert says it lacks critical context. The AI could not make a final decision, so it pushed the alert to the SOC team. Imperum is a full AI platform. Imperum isn't a ChatGPT wrapper. We layer RAG, CAG, and GAR to turn raw data into actionable environmental intelligence. We run full on-prem RAG with CAG. That means a small model is trained in real time on each customer's unique data, and that data remains on the customer premises. I will show that later. In this case, the AI did not have enough context, so it asked the team for help. We also have full memory. You can accept the AI decision or override it. The system remembers both. If I accept the decision now, the AI records that it made the correct call. Every AI action is stored in memory, so the system learns continuously from analyst feedback. This is alert triage. The next capability is case management. You can use card view, table view, or Kanban view. Different analysts prefer different ways of working. You can also see that Vertis Triage is pushing a lot of tickets. That is because it could not confidently determine whether those alerts represented real issues. The alerts simply did not contain enough information. This is how AI should work. Some vendors present AI as if it will do everything. That is not realistic. AI will help a lot. But in some cases, it should ask for human help. That is the correct model. Some alerts contain rich context. Others simply say, alert on endpoint, and nothing more. In that case, AI cannot make a reliable decision. So the system pushes those alerts into case management. Now you can see many cases being created. The second AI capability here is case prioritization. We take the case, evaluate the signals, apply deterministic scoring, and then let the LLM assess whether the case is truly medium, high, or low. We check 8 signals. That includes alert severity, IOCs, entities, affected scope, and business context. Then we present the analyst with an informed recommendation. For example, this alert came from Defender as medium severity. Imperum recommends low. This is our second AI feature, case prioritization. It helps the analyst focus on the real cases. Traditionally, teams receive a high-severity EDR alert and then run a playbook to downgrade it. But that requires building a playbook for every scenario. Here, there are no such playbooks involved. The alert comes in, the LLM analyzes it, and returns a severity recommendation. If you open the case now, you can see why it recommended low. The original alert came in as medium, but the recommendation is low because alert velocity is low, MITRE is not present, IOC activity is limited, and the business context is normal. The asset is a normal endpoint, not a server, and the data is not marked as confidential. So this is how AI helps adjust case severity instead of relying only on the originating technology's severity label. The same review model applies here. You can accept the recommendation or override it, and the AI memorizes that outcome. This is the right way to reduce false positives and hallucinations. Use RAG, which we do, and keep a human feedback loop with the AI. That is how you maintain a healthy AI capability in the SOC. From the case view, you have everything here. You can see the overview, the summary, and the related events. If the case went through triage, you can see that too. You also have a timeline showing what happened and when. And if you want to run playbooks, that is available here. We still have a full hyper-automation platform. We also have chat. You can assign the case to team members and they receive push notifications. You can communicate directly inside the case. For example, Carlos, Sylvia, analyze this. Give me a PCAP. Do this investigation. So you have full case-based communication built in. Next, we have a war room. If you want to promote a case to a war room, you do it here. Then you can invite the customer into that war room. You click Start a War Room, and the customer receives a magic link. When they open it, they only see that specific case. From there, you can continue communication with the customer, assign tasks, and let them follow the incident directly. This is the case management module. Now let me show you the modules because this is important when you manage many customers. We have a unified dashboard here. You click it and see all customers and all alerts in one place. Now let me show you Modus. Modus is where you define alert grouping. For example, you can group by hostname, source, or destination. But the most important part here is casebook logic. We still call it casebook logic, but it is really becoming SOC logic. Originally, this module was only for casebook. Now it covers much more, so we will rename it soon. This is where you define operational logic. And this is fully multi-tenant. You can say, for customer A, when a Microsoft Sentinel alert arrives, send it to Vertis Triage. Then you define how AI should work. For example, full RAG with a 2-minute window. If the asset is a server, perform deep AI analysis and wait 5 minutes. So here you control exactly how the AI is used. Everything is transparent. You can configure confidence, threshold, heat, and all related controls. You can also allow access to the customer's RAG data, which is trained on that customer's own data. Then, when Virtus Triage decides to close, escalate, or assign the alert to an analyst, that logic is applied here. You can also trigger a pilot investigation. So for customer A with Microsoft Sentinel, that is one workflow. For Microsoft Defender and customer B, you can define another. For example, if a Microsoft Defender alert for customer B maps to certain MITRE techniques, then trigger a playbook. That is how you build the operational logic of your SOC. You can also define that if a customer uses Cisco EDR, alerts should go directly to Virtus Pilot without going through Triage. Virtus Pilot is our investigation agent. It performs a full investigation. Again, you can define memory behavior, RAG usage, and whether it should run fully autonomously. This is where you define the operational logic of your SOC using drag and drop. And as I said, this is fully multi-tenant. You can apply different logic to Imperum BV, Imperum Inc., or any other tenant. We also have full forensics, which I will not go into in detail right now. We also have full detection. That includes Sigma detections, threat intelligence, and machine learning. These detections work with syslog, and we have a full syslog backend to support that. Under Endpoint, this is our forensics agent, which can be deployed on any operating system. Now let me show you a recent investigation. I told the forensics agent, bring me a packet capture from my laptop. It brought back the PCAP. I clicked Analyze, and the system parsed it, analyzed it, and presented the full capture. So you no longer need to download a capture and open Wireshark manually. You can retrieve a PCAP from any operating system directly in the platform. And because we have a technology alliance with CrowdStrike, we support CrowdStrike customers as well. Usually, EDR products do not provide real forensics capability. Here, you have full forensics capability. It is a separate module, very deep, and very powerful. You have real-time scanning and hands-on investigation capability, but I will move on to the next modules. The MSSP Unified Dashboard lets you see everything happening across tenants. Next is Playbooks. We now have a very strong email triggering module. You can add your provider here, and we support all major providers. Then you define your templates. We have templates for phishing email, vendor alert, compliance, and more. You can also build your own template and define the interval. If you go into Automatio Studio, you can see that we can trigger a playbook using an API call. When you choose a trigger, the platform automatically detects all available alert types from each technology. For example, Cisco Secure Endpoint provides specific alert types, and Imperum knows exactly which ones. So you can say, when Cisco EDR sends a vulnerability application detection alert, trigger this playbook. Second, we support webhook triggering. Third, we support email triggering. If you select email, you choose the mailbox provider. The platform can monitor the inbox every 60 seconds. Then you define profiles. For example, if you want a phishing workflow, the platform automatically performs content analysis, phishing checks, and authentication validation, and then triggers the playbook. So at the moment, we support 3 playbook triggering mechanisms. You can build playbooks in code, through a wizard, or using AI. You can also ask AI to build playbooks for you. Everything is multi-tenant. You can deploy to one tenant or across multiple tenants. This is our hyper-automation capability. Next, I want to jump to Marketplace. Marketplace is about connectors and supported technologies. Here, we provide full end-to-end coverage, from alert ingestion to normalization. We currently support 1,548 technologies. Another 1,000 are ready but not yet published, so we expect to reach around 3,000 in total. We also support 41 webhook technologies right now, and that number is growing continuously. Again, this is fully multi-tenant. If you select Show Only Deployed Connectors, you can see something interesting. For example, Logarithm is deployed through a VPN. That means this customer has an on-prem Logarithm environment connected through VPN. If I switch to another environment and filter Deployed Connectors, you can see that Splunk is deployed on a remote instance, while OpenVAS, WASA, and MISP are deployed over VPN. This means two things. First, Imperum supports remote tenants. This is a dedicated remote Imperum instance deployed on the customer premises, connected to an on-prem Splunk. From here, you have two deployment options. You can deploy a full stack with AI and keep everything fully on-prem, then forward only the alerts back to the main Imperum platform. Or you can deploy in proxy mode. In that model, you run an Imperum proxy on the customer premises. All on-prem technologies connect to that proxy, and the proxy forwards the data to Imperum. In this example, it is running in proxy mode. If you open it, you can see that Splunk is connected with a 43 millisecond response time. This Splunk environment is on-prem and has no internet connection. You can see health, logs, and proxy activity. You can also access terminal, backups, and SSH-based control. That is important in distributed environments. SSH here runs through a WebSocket. There is no manual SSH configuration required. Everything is one-way WebSocket, so there is no extra firewall complexity. That is how the remote model works. Now assume the same customer also has IBM QRadar on-prem and wants to connect it here. You select QRadar, choose the customer, and Imperum detects that the customer already has a remote Imperum instance deployed on-prem. You click Deploy, and Imperum deploys the IBM QRadar connector directly on that remote instance. Again, this is fully multi-tenant. You can create subcategories, define SLAs per customer, and assign analysts per customer. So this is the remote dedicated instance model. Now let me show you the VPN model. You already saw that several connectors were connected through VPN. Here is how that works. You go into Settings and define a VPN profile. Imperum has its own VPN server and gateway. You can add a profile here, and customers can use WireGuard, OpenVPN, or IPsec. In this example, I am using IPsec. This is a direct IPsec VPN from Imperum itself. There is no need for separate firewalls or VPN concentrators. The platform handles this. You can see the direct IPsec connection here. It is already connected. Now let me deploy QRadar again. When you go into the connector settings, you can assign that connector to the IPsec profile. So a connector can be assigned directly to a VPN profile. This is very simple operationally. Imagine handling 50 or 60 customers with on-prem solutions. You do not need to build separate complex VPN architectures for each one. Each connector has its own built-in VPN client and can securely connect to the customer's on-prem technology. Now let me show you the agentic capability. At Imperum, we have agents. Here, we are not using traditional playbooks. What happens here is that we take a Microsoft Defender alert from EDR, and the LLM builds an investigation plan. For example, it decides, I will search for the domain, I will search related events, I will inspect processes, I will check cmd.exe because those indicators are present in the alert. The LLM builds a 15-step plan. Then it determines that this appears to be a failed login detection related to Azure portal access. From there, the LLM reaches out to Microsoft Sentinel, retrieves related failed login events, sends relevant artifacts to VirusTotal, analyzes the results, and builds a graph. This is AI-driven investigation. This is graph-augmented retrieval in action. The system also builds the knowledge context and prepares a report. For example, there was a failed login. This requires investigation. Let me show you another EDR alert. In this case, from Defender, the system says, "This investigation faces significant challenge due to missing critical entities." There is no host process, so the agent could not fully investigate it. Another example shows a sysmon event. This investigation is focused on network activity to docs.microsoft.com, which may indicate legitimate Microsoft activity. Everything can be pushed into agentic investigation. You can also see where steps failed. For example, VirusTotal may not have returned anything. This is a pure agentic workflow. Here you can see the statistics, how many LLM tokens were used, which APIs were called, and what the execution limits were. So this is a full agentic workflow. How many of these workflows do we have? Let me show you. We released Agent Studio last week. In Agent Studio, you can build any agentic use case you want. Some vendors sell one agent for triage. Others sell one agent for investigation. Others sell one agent for something else. In Imperum, we already have 107 predefined agents, and more are coming. The team is currently building toward 200. Each of these agents is ready to deploy. For example, take phishing investigation. You click it, see the visual graph with 9 nodes, use the template, and deploy it. You can then edit it. This is the agentic editor. You build agents here using drag and drop. You can customize them, build them, test them, and deploy them. This is highly differentiated because we provide an editor that lets you build your own agentic AI workflows. You are no longer dependent on Imperum to build them for you. You can see here that the system performed RAG search. It searched alerts, then searched the RAG. This is advanced capability. It does require some understanding, but it is not overly complex. If you do not want to build from scratch, you can choose from the catalog. You can also generate custom agents in 3 ways. First, you can generate a single action agent. This is based on a single prompt. For example, if I need a phishing agent, I choose that, click Next, name it Enrichment Agent, and the system prepares the prompt that will be sent to the AI. Then I click Next, and the AI automatically selects from the technologies already connected to Imperum. This is powered by our MCP gateway, which translates standard APIs into AI native tools, allowing the LLM to actually drive your security stack. Then you click Next, choose the temperature and other settings, and deploy the agent. That is one method, a simple agent using a simple prompt. The second option is a structured agent. This is typically what the SOC team uses. Analysts and operators usually work here, not in the full editor. The full editor is more for advanced detection engineers. With the structured option, you still provide a prompt, but now you control each step of the AI workflow. You can use one prompt here, another prompt there, and build a fully customized logic path. For example, get me the alerts. Then you deploy it. This is the second approach, and this is the one we usually see customers using. Some of our older customers are already using it because their SOC teams are experienced and understand it quickly. The full editor is more advanced. There, you need to understand how LLMs and RAG work. To make that easier, we provide templates. For example, if you want to build a threat hunting agent, the template is already there. You only modify it and deploy it. This is a separate license. We plan to release it next month, and it should include around 200 agents. This will be very useful. Now let me show you deployment. You can see agents already started. Now I have a phishing agent. I configure which alerts should be sent to this agent. That is done very easily. For example, with Microsoft, you can send either normalized alerts or raw alerts. Sometimes LLMs perform better with raw alerts than normalized alerts, so you can choose. If you choose normalized and select Microsoft, the platform detects that Microsoft Defender can generate 20 different alert types. Then you specify exactly which alert type should be sent to this agent. Once you save it, the agent is now fed by Microsoft Defender for that specific alert type. This is very simple. For a more advanced agent, you may want to send direct API alerts. That is also supported. So this is Agent Studio. You have everything here to deploy your own agents. You are not dependent on the Imperum team to build them. If something does not work, you can always open a case with us. All agents are here, and all of them are ready to use. Many of them are structured. We currently have around 100 structured agents already prepared. For example, this alert requires immediate action. That is the prompt sent to the AI. Then the system calls the tools. Everything is already built. Now these agents need to talk to a capable MCP, and we have that too. We now have an MCP backend and MCP gateway, both built with Imperum technology. At this point, all of these connectors and technologies are essentially standard API integrations. They are not AI native by themselves. What you do here is publish those technologies into the Imperum MCP platform. You can see that many are already published. Then, look what you can do. Take VirusTotal, for example. VirusTotal does not have its own AI layer, but through Imperum MCP, you can interact with it conversationally. For example, is 8.8.8.8 clean? Now the AI agent determines which VirusTotal API it needs to call. It formats the request, sends it, receives the response, and formats the result for you. You can see that here. It identified the correct report call, formatted the arguments, sent the request, and returned the result. This is another major differentiator. Imperum now has around 1,450 technologies published into the MCP gateway, and another 1,000 are coming. Let me show you another example. Take Microsoft Defender. If I say, "Show me recent alerts," the LLM determines which API to call, whether to retrieve alerts or events, pulls the data, formats it, and presents it. You can see the output here. I am not telling it which API to call. It is building the API interaction itself, calling it, and returning the result. You can also see the execution log and the session. Now you can see that the agents I deployed are using my MCP, and I can see exactly which API calls failed. We also have self-healing. Every failed action is sent back to the LLM. The LLM tries to determine why it failed, corrects the mistake, retries it, and prevents the same failure from happening again. Everything supports self-healing. Of course, calling APIs from AI introduces risk. That is why we classify risk levels for actions. Some actions are low risk. Others are medium risk, such as updating an alert. Others are high risk, such as approving or rejecting remediation actions. The LLM understands exactly which API calls are risky, and you can define that certain actions must never be touched by AI. Now let's look at Virtus.ai engine. This is how AI works inside Imperum. Here you can see Imperum Core, where Imperum is installed. RAG is Retrieval Augmented Generation. It is a very fast database, but it is not intelligent by itself. To make it intelligent, we add KAG, Knowledge Augmented Generation. We inject knowledge into the data layer. Then we build GAR. When you combine these three, you get this. This is a GAR graph. This is an AI graph. Because we train a small model on the customer's live data, we can visualize the environment for AI. The AI understands connectors, alerts, hostnames, and relationships in that customer environment. Here it is. You can see the GAR. This is also where memory is maintained. For example, you can see 5 memory entries here. You can see where I corrected the AI. You can see how often the AI was corrected, which cases were involved, and everything the AI is doing in a transparent way. So this is how AI works at Imperum. Here you can also see that all customer data is used to train a small LLM in real time. In the RAG settings, you can upload customer data such as documents, previous alerts, investigation history, or anything else you want to make available. You can also sync threat feeds into the RAG. That is extremely useful because threat feeds are structured data. RAG itself is structured. It is not a basic MySQL database. You can index incidents and cases in real time so that RAG understands what is happening operationally. Once RAG is fully in place, you can see that playbooks and other artifacts are all available there. Then we add knowledge to the database. We tell the model, for example, these 278 items are alerts. These 29 items are playbooks. These playbooks are used in SecOps for these purposes. This is how we give semantic knowledge to the system, so the LLM understands the environment. Then we fill the GAR module as well. At that point, you can decide which LLM model to use. For example, you can choose Cloud LLMs. You might select Anthropic Cloud, enter the API key, test it, and save it. Imperum then automatically informs you about the privacy model being used. For example, this is a hybrid privacy model. That means customer data does not leave the customer environment, but analysts may still ask questions such as, why did John admin trigger 47 logins from this IP? That could leak sensitive information. To prevent data leaks, we built Veil. It intercepts and redacts PII before it ever hits a Cloud LLM, keeping your investigation secure and compliant. You will find startups that have raised millions for exactly this capability. For us, it is built directly into Imperum. When Veil is enabled, if an analyst sends a question containing PII, Imperum intercepts it, redacts the user and IP information, and only then sends it to the Cloud LLM. That is for public Cloud LLMs. You can also run private Cloud LLMs. That can be in your Azure environment or your own data center. And you can also run fully on-prem. When you run fully on-prem, you get additional visibility. Many vendors charge per token or per investigation. We do not do that. Instead, we provide AI usage visibility. You can see exactly what AI will cost for each customer. For example, you can see that one Vertis Triage request costs a certain amount. We can calculate precisely how much AI costs across the customer base. Then, if you switch to local, I will now switch to local, you can run your local LLM. Now you will see something very useful and very unique. When we started Imperum AI, we were among the first autonomous SOC platforms using local AI. We were never a ChatGPT wrapper solution. That is why we needed this architecture. This was the cloud setup. Now I switch back, detect my Llama models, and here I have DeepSeek. I test it, DeepSeek is available, and I save it. Now if I go to AI usage, the platform automatically detects that the model is running on my GPU locally. It shows how many parameters it has. Then it automatically calculates. This GPU can handle 45 tokens. With this GPU, you can run 81 alerts per hour. You can run 20 cases per hour. So here is your bottleneck. If the customer sends more cases than that, capacity becomes a problem. We provide full visibility into AI performance and SOC operational capacity, including how much GPU you need. You can also run simulations. You can say, tomorrow I will have 50 customers sending 200 alerts. Then, Imperum simulates the required GPU capacity. You can also see exactly how many tokens were used for each AI-driven action. There is much more in the platform, but these were the most important capabilities I wanted to show you. Ultimately, Imperum doesn't just give you an AI. It gives you a transparent, scalable, and forensics-ready SOC infrastructure that grows with your GPU capacity, not your headcount.